All right, without graphing, what is the x-intercept of this function? Okay, what do you know about x-intercepts? Anything? Okay. Right. We all know that a y-intercept is where it hits the y-axis, so an x-intercept is where it hits the x-axis, so a point would be on the x-axis. Well, think about it. I know it said not to graph it, and I'm not going to graph it. I'm just going to draw an x and y-axis. We all know that the horizontal axis is the x-axis, and the vertical axis is the y-axis. So to be an x-intercept, the point has to be sitting somewhere directly on the x-axis. Well, for that to happen, for it to sit directly on the x-axis, means that it did not move up or down the y-axis, right? So what would its y value have to be? 0. Okay, an x-intercept always will have a y value of 0. That's why it's still sitting on the x, because it went nowhere on the y, so that would be C. So a y-intercept would always have what? A 0 in the x place. So for this one, the y-intercept would have been, right, A, 0, 1. Okay? Y-intercepts always have a 0 for the x value. X-intercepts will always have a 0 for the y value. Otherwise, they wouldn't be sitting on the axis. They would be sitting in one of the quadrants. Does that make sense? Okay, now we're going to check homework. And you can also, I'm checking page 2 and 3. And then after I've done that, we will be working on page 5. So go ahead and get out that homework for me to check. Okay. All right, the formula for density is D equals mass divided by volume, where M is mass, which I just said, and V is volume. If mass is measured in kilograms and volume is measured in cubic meters, what is the unit for density? Now, I know this seems difficult, but it's actually very easy. All you're doing is taking this equation that they gave you for density, and they want to know the unit for density. So all you're doing is replacing the letters with what they're measured in. So you would just do density equals M, but instead of M for mass, we're now going to replace it with its units, which is kilograms. And then over V for volume, but what is volume measured in? Cubic meters, and we write that as M-E. And that's all you do, you're done. All right, number 2. The formula for force is F equals ma, which is mass times acceleration. If mass is measured in kilograms and acceleration is measured in meters per second squared, what is the unit for force? So you're just going to rewrite it, but instead of M for mass, we'll put kilograms, because that's the units for mass. And then they're touching, so this is multiplication. A for acceleration is measured in meters per second squared. And then you may actually see them simplify that once more. Instead of keeping it like that, remember with fractions, multiply the numerators, multiply the denominators. Well, the numerators are kilograms and meters, so it would be just kg times m. And then the denominator is just second squared. So they may just go ahead and combine it like that. All right, the next one. The formula for velocity is V equals d divided by t, where d is distance, t is time. If distance is measured in meters and time is measured in seconds, then that is the unit for velocity. Velocity equals meters per second. And so all you do. So why don't you try the next one before I do it with you. Go ahead and see if you can figure out what that one should look like once you've replaced it with the units. All right, I'm not sure what number it is, 5. For the question above, force and area can also be measured in metric units. Now let me talk about what they mean by that. We use the standard system of measurement in the United States. So we use things like pounds for weight, inches for length. But in most other countries in the world, they don't use the standard system. They use the metric system where instead of pounds, they use like kilograms or newtons. And instead of inches and feet and miles and stuff for length, they use like meters, centimeters, stuff like that. Okay, so that's all the metric system. So for the question above, force and area can also be measured in metric units. If the metric unit of force is newtons and the metric unit of area is square centimeters, what would be the metric unit for, this should say pressure again. Okay, so you're just using the same formula for pressure, but this time, instead of pounds, in the metric system, force is measured in newtons, so you would put N in the numerator. And then for area, instead of it being square inches, it's measured in square centimeters, so centimeters squared. And then that's the answer. All right, last one. The cost in dollars of a single-story home can be approximated using the formula C for cost equals KLW, where L is the approximate length of the home, W is the approximate width of the home. Find the units for the coefficient K if width and length are measured in feet. So we don't know anything about the cost, and K is a constant, like how much it costs per foot and for the length and width. So we're just going to leave K as itself. But what did they tell you length is measured in? Feet. And isn't this K times L times W? So K times feet times, what is width measured in? Feet as well. Okay, so the cost is measured in K, which is just a constant value, times feet times feet. Well, instead of leaving it like that, how else could you write feet times feet? Feet squared. So it would look like that. Okay, now flip the page and we're going to go to something even easier. April, put it up on the wall, please. All right, number 1, the directions say determine which choice best answers each question. Number 1, which choice best represents the height of a refrigerator? 6 yards, 6 inches, 6 miles, or 6 feet? How tall is an average refrigerator? Out of these choices anyway. Is it 6 yards? Okay, let's talk about a yard. 1 yard equals what? 3 feet. So that means 6 yards would be how many feet? How many? 18. Is your refrigerator at home 18 feet tall? No. Is your refrigerator 6 inches tall? Is it 6 miles? Is it 6 feet? Yes. So that would be the best approximation of a refrigerator's height. Choice 2. Which choice best represents the height of a birthday candle? 2 yards, 2 feet, 2 miles, 2 inches. 2 inches. 3. Which choice best represents the height of a tennis ball? 3 miles, 3 feet, 3 yards, 3 inches. 3 inches. Number 4. Which choice best represents the length of a pen? 5 miles, 5 inches, 5 feet, 5 yards. 5 inches. Number 5, which choice best represents the width of a sheet of paper? 8 yards, 8 inches, 8 feet, 8 miles. 8 inches. Number 6, which choice best represents the length of a loaf of bread? 12 yards, 12 inches, 12 miles, 12 feet. 12 inches. Number 7, which choice best represents the length of a football field? 120 feet, 120 miles, 120 yards, or 120 inches? 120 yards, right. All right, number 8, which choice best represents the length of a football? 11 feet, inches, miles, or yards? Right. Number 9, which choice best represents the height of an adult elephant? 4 yards, 4 feet, 4 miles, 4 inches. Okay, well, let's cross out the obvious no's. 4 inches, no way. 4 miles, no way. Is an elephant 4 feet tall? No, that's shorter than you. So it would have to be A. 4 yards is what? How many feet are in 1 yard? 3. So how many feet are in 4 yards? And doesn't that sound about right for an elephant 12 feet tall? So A. All right, number 10. Which choice best represents the height of a tree? Now we're talking about like a tree that has been there for a while, that is fully grown. 6 feet, 6 inches, 6 yards, 6 miles. 6 yards. Okay, because that's how many feet? How many feet is 6 yards? 18, because there's 3 feet in 1 yard, so 6 times 3 would be 18 feet. Number 11. Which choice best represents the height of a door? 7 yards, 7 feet, 7 miles, 7 inches. 7 feet. Number 12. Which choice best represents the length of a bug? 1 yard, 1 foot, 1 mile, 1 inch. 1 inch. And then number 13. Which choice best represents the height of a sheet of paper? 11 yards, 11 inches, 11 miles, 11 feet. Right? Number 14. Which choice best represents the distance from New York City to Albany, New York? 150 feet, 150 yards, 150 miles, 150 inches. Right, miles. Which choice best represents the height of a mountain? 2 inches, 2 yards, 2 miles, 2 feet. Right, it has to be 2 miles. 2 inches is way too small. 2 feet is too small for a mountain. And 2 yards is even too small, because 2 yards is only how many feet? 6 feet. Okay, now, the next page you're going to work on your own, and I'm going to come around and stamp for it. That way you at least have 2 stamps for this one, and that'll help out anybody that got a late stamp for today's. It'll at least average you out to an 85 for the whole thing. So go ahead and work on this for the next few minutes, and then I'll come around to stamp it before. Okay, so today we're going to be learning about how do I convert from one unit to another. All right, sometimes we want to change one type of measurement unit to another, like such as converting inches to feet, and this is called converting measurements. Okay, so when we want to change one type of measurement unit to another, that's known as converting measurements. Like we talked about earlier today, in the U.S. we use the standard system of measurement. Here are some standard system measurements and their equivalent units. For length, we use things like inches, feet, yards, and miles. Okay, and here's just a few basic conversions, like 1 foot is 12 inches, 1 yard is 3 feet, 1 mile is 1,760 yards. For weight, we use ounces, pounds, tons. 1 pound is 16 ounces, 1 ton is 2,000 pounds. And then for capacity, we use things like teaspoons, tablespoons, fluid ounces, cups, pints, quarts, gallons. Okay? Now, we're going to be needing to refer to these for what we're doing today. So what I'm going to do is try to move it over here so we can reference it. Okay, and then on the next page, we'll start with that example 1. All right, how many quarts are there in 10 pints? We are going to create what's called a conversion chain. Now, I know that some of these are super easy and some of you would be able to do it in your head or just without the conversion chain. But some of these conversions we're doing over the next week are going to be a little involved. And if you know how to do the chain, then it's a procedure you can use every time and always get it right, okay? So at least learn how it works, even if there's some problems that you don't have to use it on, okay? You always start your chain with what they've given you. They've told you that we have 10 pints, and we're trying to figure out how many quarts that is. So 10, and then PT is the abbreviation for pints. Okay, now we're going to multiply that by a fraction. The rule is whatever is in the top has to go in the bottom of the next one. So since pints was in the top, we have to put pints in the bottom of this fraction. Now, do we know anything about pints and quarts over here? Look over here. What do we know about pints and quarts? Right. We know that 2 pints is the same thing as 1 quart. Okay, does everybody see what I did? Okay, now, we're now finished with our conversion chain because we've made it to our goal. Our goal was to get to quarts, and we've made it. See how we've made it to quarts? Now, these cancel each other out because remember, anything on top and bottom is just 1, so you can cancel it out. And now we just simplify. 10 times 1 is in the top, which is 10. The only thing in the denominator is a 2, and then that reduces to a 5. So that means in 10 pints, there's 5 quarts. Okay, now let's look at example 2. How many pints are there in 64 fluid ounces? Okay, so what do we start our chain with? Right, so 64 and then OZ. And now we're going to multiply that by our first fraction. And remember, the rule is, if you have ounces in the top, ounces has to go in the bottom of the next one. Do we know a conversion from ounces to pints? The only thing they tell us about ounces down there is what? Okay, we do know that. We know that 1 ounce is 2 tablespoons. But remember, we're trying to get to pints. So we could even start a little lower because we're trying to get to pints. So couldn't we go and say 8 ounces is 1 cup? 8 ounces is 1 cup. Now that we have cups in the top, in our next fraction, cups has to go in the bottom. And what do we know about cups? Isn't 2 cups equal to 1 pint? So 2 cups is the same thing as 1 pint. Okay, now that we've made it to our unit that they want us to get to, pints, that's what we've made it to in our chain, so we can stop our conversion chain and simplify. Ounces and ounces cross each other out, and so do cups and cups. And now you just multiply straight across the numerator, straight across the denominators. 64 times 1 times 1 is 64. 8 times 2 is, and what is 64 divided by 16? 4, and then remember that's pints because that's all that was left that didn't cross out. So there are 4 pints in 64 fluid ounces. All right, now example 3. How many feet are in 4 miles? What do we start our conversion chain with? 4 miles, because that's the only thing we know right now is 4 miles. Okay, remember, when you start your chain, the rule is Whatever's in the top, whatever unit it is, goes in the bottom of the next one. Now, do we know anything about feet and miles? What do we know about miles? Right, 1 mile is 1,760 yards. But we can't stop our conversion chain yet because we're only in yards and our goal is to make it to feet. So we got to continue it. Since yards is in the top, yards goes in the bottom. What do we know about yards? 1 yard equals 3 feet. Okay, now we've made it to feet. That was our goal, so we can stop the chain because we've made it to our unit goal where we want to be. Miles and miles cancel each other out, so do yards and yards. Now we're just going to multiply straight across. So you'd multiply that 4 times that 1,760 times 3, and that gives you 21,120, right? And then on the bottom, wouldn't you just have 1 times 1, which is 1? And so you no need to write that on the bottom. And remember, this is feet because all the other units canceled each other out. So there are 21,120 feet in 4 miles. Okay, last example. How many ounces are in 28 pounds? So what do we start our chain with? 28 pounds, so 28, and then LB is the abbreviation for pounds. Now we're going to multiply that. What has to go in the bottom of the next fraction? Pounds. Do we know anything about pounds straight to ounces? Yeah, look, 1 pound equals 16 ounces. 1 pound is the same thing as 16 ounces. So now we can stop our chain because we've made it to ounces. That was our goal. Pounds and pounds cancel each other out, leaving 28 times 16 in the numerator, which is 448, and then only 1 in the denominator, which you don't have to write, and then that's ounces. Okay, we'll continue working on these Monday. You can go ahead and switch out. Don't forget